Rashida binti Ismail.
Hi, my name is Noorina Safwa binti Zainal.
My name is Nur Atira Shazwana binti Kamal.
My name is Nurna Farhana binti Azman.
The main objective of this study is to identify hazards that arise in metal fabrication industry. This study was conducted by literature search using ResearchGate, academia.edu, and PDF Room databases to find any journal, articles, and research paper that is published in English language. The results was classified from a literature search by broad categories of study outcome into physical hazards, radiation hazards, dust and chemical hazards, and economic hazards. We are able to identify related hazards in metal fabrication industry, and the control measures for the hazards includes elimination, substitution, engineering controls, administrative controls, and PPE. This cross-sectional study is aimed to evaluate occupational health and safety risks in metal fabrication industry. Metals are used in building structures, ships, and vehicles, including cars, trains, and trucks. There are many metal fabrication industry in this world, and many employees experience various types of hazards without realizing it, such as physical hazards, radiation hazards, dust and chemical hazards, and economic hazards. In order to avoid and eliminate the hazards, control measures for each hazard will be researched.
I will be introducing about the background of the industry, issues and problem statements. Metal fabrication industry is critical to the safety of a variety of industries, from aerospace and automotive to defense and medical. This is because metal fabrication can be used to make various components, structures, and parts that have the required design, strength, and precision. Industrial metal fabrication involves the processing and shaping of metals into useful components, parts, and products. These metals can be used in a variety of applications, including tools, furniture, machinery, and vehicles. This process requires a variety of skill and techniques. When working with metal, there are a number of risks that employees may encounter if appropriate safety precautions are not taken. To produce and fabricate metal continuously and around the clock, operation using shearing machines, rolling machines, drilling machines, welding machines, and fastening tools, making workers exposed daily to hazardous materials such as toxic and explosive gases, vapors, dust particles, and heat. Several studies, reports, and occupational health organizations have highlighted some prevalent occupational illnesses commonly associated with metal fabrication and similar industries. There are significant environmental effects associated with the metal sector at every level of production, from raw material extraction and processing to fabrication and end-of-life disposal. However, the plant's health and safety culture were weakened by a lack of knowledge about the particular health risks connected to various processes in the steel processing facility. The main objective of this project is to identify hazards that arise in metal fabrication industry. To achieve this overall objective, three specific sub-objectives are planned. Firstly is to study the effects of hazard factors that can lead to health issues of workers and the community. Second is to analyze the impact of metal waste that affect the environment. Third, to propose suitable corrective action to reduce the risk or elimination of hazard. Implementing measures to uphold a secure working environment in the metal business, this study will protect the employer from risks associated with mishap and injuries.
Metal fabrication is the process of forming, cutting, or molding various metals into the required shape or form. The product to be developed and the metal substance to deal with are taken into consideration during the production process. In other words, metal fabrication refers to the process of taking metal sheets or plates and transform them into a custom part, components, or end product by employing various metalworking processes like cutting, bending, welding, and machining. Metals or alloys commonly used for custom metal fabrication including aluminium, copper, iron, magnesium, gold, silver, and titanium. Some typical methods are used in metal fabrication, for example, casting, forging, welding, cutting, and punching. Depending on the materials and intended result, a variety of different fabrication techniques can be applied. So the first process is forging. Forging involves the shaping and reshaping of solid metal into the desired part of product. In this process, a piece of metal is struck with a die or hammer to obtain the required shape. So next process is cutting. Cutting is the one of the most common types of fabrication processes. It involves cutting a piece of metal into a smaller section. Machining includes a few combinations of process, which is cutting, drilling, grinding, and also milling. Other than that, machining is also an automated process that makes use of a computer program to guide a machining tools according to a predefined set of parameters. The process is refers to the process of joining materials, typically metals such as aluminium, cast iron, steel, and stainless steel, together using a high heat and pressure. Shearing process is a process to produce a long and straight cut. Throughout the process, two tools are used. A piece of metal has one tool position above it and another one below it. The metal is forced downward by pressure to break it.
Occupational health and safety hazards in the metal fabrication industry. The major safety problems and concerns for the structural metal manufacturing businesses were those that can lead to occupational injury, musculoskeletal problems, or death. These hazards generally correspond with common mechanisms of injury and disease reported in workers' compensation claims for this particular industry. Physical hazards are common in the metal fabrication sector because of the nature of the operation, which involves heavy gear, sharp tools, and the handling of metal components. There are three parts in these physical hazards. Firstly is the noise hazard. The sources of noise that are commonly found in this work process includes angle grinders, metal presses, cutting saws, and hammering and bashing on metal objects. The workers may be engaged with this type of exposure repeatedly during each shift and consequently affect their hearing, as impact or impulsive noise can be more harmful than steady-state noise. Permanent hearing loss is primarily found among the industrial workers who are continuously exposed to high-intensity noise in the long term of employment. Secondly is the vibration hazard. Vibration takes the form of, first, hand-arm vibration, and second, whole-body vibration. Hand-arm vibration impairs subjective perception, fine motor skills and performance, and may, after years of exposure, cause circulation disorders, nerve function disorders, muscular tissue changes, and joint damage. Whole body vibration on mobile machinery and equipment. Whole body vibration may impair the senses and may lead to balance disorders, kinetosis, or visual disturbances, impair fine motor skills or reduce performance, cause stomach troubles, and affect the spine. Lastly, machine is one of the key factors for the fabrication engineering industry and is one of the industrial mainstays of the competitive economy. However, their moving parts and sharp edges and hot surfaces can also cause serious workplace injuries such as crushed finger or hands, amputations, burns, or blindness. Sharp edges can cause cuts and severing injuries. Sharp pointed parts can cause stabbing or puncture of the skin, and rough surface parts can cause friction or abrasion. People can be crushed both between parts moving together or towards a fixed part of the machine, wall, or other object, and two parts moving past one another can cause shearing. Parts of the machine, materials, and emission, such as steam or water, can be hot or cold enough to cause burns or scalds. For the next part, dust, chemicals, and hazardous substances in metal fabrication industry. During numerous procedures, workers in the metal fabrication businesses are frequently exposed to a variety of dust, chemicals, and dangerous substances, which can present serious health hazards. Workers are exposed to a variety of harsh chemicals during working hours, including paints, solvents, hexavalent chromium, and cleaning fluids. Without proper PPE, workers may experience chemical burns or any other type of skin irritation. Repetitive and prolonged exposure to these chemicals can prove toxic to the worker and severely affect their skin or respiratory system. The major heat, noise, and fume generating process in welding, which is critical to activities carried out in any fabrication shop. Besides untarred road, which compound the air pollution through dust from the roads, the welding type are common to all the shops are gas welding and electrical arc welding without welding both in place. Radiation hazard in metal fabrication industry. In the metal fabrication sector, the majority of radiation-related risks are related to procedures that involve equipment that emits radiation. Even while there isn't as much of a risk of ionizing radiation exposure as there is in sectors like healthcare or nuclear powers, it's nevertheless critical to recognize and control these risks. In recent years, much evidence have shown that emission of UV radiation may act as a dangerous factor in the formation of human cataract. Comparing the symptoms of keratoconjunctivitis show that eye redness and hotness, tearing, photophobia, and sensation of sand in the eyes, painful eye inflammation, eyelid inflammation, and eyelid and face inflammation were more common in welders than in non-welders. UV radiation causes dermatitis in welders and increase the risk of melanoma and erythema. Economic hazards in metal fabrication industry. Welding operation is faced with a number of safety and economic challenges because of the emissions from fume, heat, or sparks that occurs during the operation. Likewise, the dynamic posture requires for the welding job and the environmental factors could lead to varying musculoskeletal disorder, which in turn causes low performance, increased frequency of accident, and absenteeism from work by the fabricators. Welding operation, as reported by the enumerator, involve frequently standing, bending, and squatting postures.
Next is effect of metal fabrication industry to environment. For this part, we can see the effect from three aspects, which are soil, aquatic ecosystem, and air pollution. For effect of metal fabrication to soil, the iron and steel making operation generate a waste of gas which is treated to gas cleaning, in which blast furnace particles are passed to the gas cleaning system. A few research projects have been conducted in the past to investigate the environmental impact of metal smelting on soil quality, and one of the research found out greater quantities of copper, lead, cadmium, zinc, and mercury near a metal production site. Other than that, the dust released by the iron smelter was discovered to have impacted agricultural soils surrounding this metal with arsenic, lead, and zinc are identified as the primary contaminants. For effect of metal fabrication industry to aquatic ecosystem, heavy metals such as zinc, copper, lead, and chromium may be released into bodies of water during metal fabrication operations. Heavy metal contamination in aquatic habitats and ecosystem also has a significant influence on the food chain. Individuals' health suffer as a result of their consumption of fish. These heavy metals have a significant environmental impact since they remain for a long period of time and have bioaccumulative qualities, leading water quality to decrease. Metal residues in contaminated environments can bioaccumulate in aquatic ecosystem, which can later enter natural human occurrences and create health risks.
Metal fabrication industry also causes air pollution. Metal fabrication and refining are among the most energy-intensive industrial processes that release greenhouse gases, particulates, trace metals, acidic gases, and organic pollutants into the environment. A high proportion of welders suffer from some form of health problem like pneumococcal pneumonia because of the fumes and gases from the welding process. Ozone, nitrous gases, and carbon monoxide are the most prevalent gases released during welding process.
For the methodology, details on the risks in the metal fabrication industry have been presented, includes the hazard identification, risk exposure, risk to workers, and risk to the environment by the following method. The first method that we are using is website. We're going through several research websites to discover relevant data to the research topic. The second is journal. A literature search was undertaken using the databases from ResearchGate, academia.edu, and PDF Room. And lastly, we're using keywords such as metal fabrication industry, metal fabrication process, hazard identification, health and safety hazards, health effects, effects of metal fabrication industry to the environment, and lastly, risk assessment and control measures to find any articles, journal, or research paper that are suitable and appropriate to our research. For the risk assessment in this research, we use the HIRAC process as stated in the Guidelines for Hazard Identification, Risk Assessment, and Risk Control HIRAC that includes 4 steps, which are classified work activities, identify hazard, conduct risk assessment by calculating or estimating likelihood of occurrence and severity of hazard, and lastly, decide if risk is tolerable and apply control measures if necessary. We use the flowchart of HIRAC process as a reference. This table shows the description of each risk and each action to control the hazard. Among the hazards mentioned in this table are poor lighting, struck with sharp and hard object, poor housekeeping such as power cables across the work area, and exposed to the heating elements.
Control measures on noise hazard. Some of the control measures that can mitigate noise hazard in metal fabrication industry are workers should wear earplug or earmuff. Display how to properly insert earplug or wear earmuff. Install isolation mounts for machines to decrease vibration transfer to nearby structures and set anti-vibration mats beneath equipment to absorb vibrations and reduce noise. To ensure success, an industrial hearing conservation scheme should also be tested twice. Control measures on vibration hazard. The most efficient way to minimize vibration exposure is through engineering controls, like use vibration damping materials such as rubber pads to absorb and reduce vibration from equipment. Workstations may design to minimize awkward posture and ensure that workers can maintain a comfortable and natural stance while handling machinery. Employers may also educate employees on the dangers of vibration exposure, correct tool use, and the necessity of reporting symptoms as soon as possible. Control measures on machine hazard. There are some machine safety measures that may be used in metal fabrication industry, such as implementation of machine safety guides, sensors, and control systems. Safer procedures and training shall be provided to workers and implemented for high critical machines. Personal protective equipment (PPE) shall be used in addition to other safety measures, but not as a substitute for other risk reduction measures or when no other control method is available. Control measures on dust, chemicals, and hazardous substances. The control measures include install local exhaust ventilation system, add personal respiratory protection equipment, and use an efficient dust collection system. Inhalation of metal fumes can cause metal fume fever and eye irritation. Control measures that can minimize the risk associated include install the air inlet above the metal furnace to suck the fumes and lead them to the exhaust gas control system and carry out air testing when necessary. Control measures on radiation hazard. Among the control measures on radiation hazard is use heat and radiation shields. Employers are required by law to ensure that their workers are properly trained. They must also ensure that their workers and anybody around are briefed before starting their work. Wearing protective clothing like long sleeve shirts, trousers without cuff, high shoes, and a cap under the helmet can protect skin from UV radiation. Synthetic materials should be avoided as they can melt and cause burns. Regular break may assist reduce continuous exposure in instances when workers are near radiation sources. Control measures on ergonomic hazard. The control measures for ergonomic hazards are including construct workstations with customizable height and angles to meet a variety of jobs and personal preference. A comfortable height and angle of work surface can reduce strain on the back and upper extremities. Choosing the right tools and equipment is an important part of controlling hazards in the metal fabricating industry. Use tools that require less force to operate and have minimal vibration can reduce the risk of musculoskeletal injuries.
Soil plays a vital role in sustaining life on the planet. Nearly all of the food that humans consume, except for what is harvested from marine environments, is grown in the earth's soils. However, owing to unsustainable population growth and rapid economic development nowadays, large quantities of poisonous heavy metal elements are directly or indirectly released into forests by human activities, which has damaged the soil quality. Firstly, the government should actively develop new types of environment-friendly pillar industries such as the automobile, biopharmaceutics, photoelectronics, and agricultural industries to facilitate sustainable economic development in the metal fabrication industry. Also, local governments should formulate urban soil environmental protection plans, organize urban ecological environmental governance, and clarify the special protection order of farm-oriented arable lands in urban areas. Moreover, scientific knowledge regarding environmental protection should be publicized. Efforts should focus on improving people's awareness of protecting the urban soil environment and strengthening their consciousness about environmental protection. Last but not least, the main sources of the soil pollution are the process that involve in the metal fabrication industry. This process will produce an industrial waste that will enter the soil by the factories. Three main methods for soil decontamination from industrial waste, which are soil can be excavated up to the specified depth, and the excavated soil can be taken away from the region and can be restored. Moreover, the soil can be restored at the same area, and keeping soil in the area is the other method. Under such circumstances, auxiliaries are added to the soil to prevent spread of infection to the plants, animals, and humans. Usually, a large plastic is drawn on the soil to prevent spread of soil pollution, prevent water from penetrating into the soil, and to prevent spread of pollution to the other regions. Excessive concentration of industrial waste from the heavy metals that were used in the metal fabrication process in the aspect of aquatic ecosystem is a big problem. Prioritizing heavy metal removal from wastewaters is required. Some of the methods that can be used are the detection technologies for heavy metals. It must be employed in industries prior to dumping waste into water bodies. Secondly, water treatment plants must be established and utilized appropriately. Industrial employees, hospital cleaning personnel, cleaners, and sweepers, among others, should be aware. These individuals will aid in the reduction of garbage from diverse sources. Thirdly, special awareness initiative for farmers and people must be developed to demonstrate the adverse impacts of excessive pesticide use in farming. People should be advised to test their fish for the presence of heavy metals before consuming them. Lastly, using the biological method to remove the heavy metals, such as the bioremediation. Bioremediation consists of several methods including biosorption, which is using dead biomass, phytoremediation, a plant-mediated heavy metal removal, bioreduction, which is the conversion of oxidation states of heavy metal ions, and lastly, bioaccumulation, which is the uptake of heavy metal ions into intracellular space. Metal fabrication processes can have several impacts on the environment, and one of them is air pollution. Governments throughout the world have already taken action against air pollution by introducing green energy. Some governments are investing in wind and solar energy as well as other renewable energy to minimize burning of fossil fuels, which cause heavy air pollution. Governments are also forcing companies to be more responsible with their manufacturing activities, so that even though they still cause pollution, they are a lot more controlled than before. Prevention from using cars and fossil fuels by encourage our family to use the bus, train, or bike when commuting. In addition, use energy such as light, water, boiler, kettle, and fireworks wisely. Recycle and reuse things will minimize the dependence of producing new things. Remember, manufacturing industries create a lot of pollution. So if we can reuse things like shopping plastic bags, clothing, paper and bottles, it can help a lot. Moreover, using control devices that are used as pollution control by industry or transportation. Control devices such as dust cyclones and multi-cyclones can either destroy contaminants or remove them from an exhaust stream before it is emitted into the atmosphere. Lastly, using baghouses to handle heavy dust loads or wet scrubber to bring the polluted gas stream into contact with the scrubbing liquid by spraying it with the liquid, forcing it through a pool of liquid, or by some other contact method to remove the pollutants.
So in the conclusion, a comprehensive review hazard identification and health exposure in the metal fabrication industry underscore the critical importance of prioritizing workers' safety and well-being. The findings reveal that the metal fabrication sector is not without its inherent risks, ranging from the exposure to hazardous substances and noise pollution to potential for physical injuries. In order to identify and reduce this hazard identification efforts have been crucial. This has made it possible to create and put into place strong safety procedure and preventive measures. The metal fabrication industry may create a work environment that more safer and healthier for its workers by encouraging a culture of shared responsibility and ongoing development. So, metal fabrication is a flexible and essential component of contemporary manufacturing due to its capacity to build and customize parts in accordance with a unique specification. So, without fabrication, we will not be able to rent electrical system and create items for our automobiles, houses, office, and the other area. So, according to the engineering control, firstly, we should install the fume extraction system. The degree of danger from inhaling the welding fumes largely depend on the materials being welded and also the electrodes being used, but there are also another factors as well. Next, install the barrier guarding around the machine. Barrier physically prevent the entry of hands or finger into the point of operation. Effective barriers should be made out of the metal and be difficult to remove by the normal employee. Also, barrier may be perforation, gaps, or opening to maintain the visibility inside the machine. In the administrative control, firstly, ensure that guidelines and hazard signs are always visible. The work area needs to be visible, access to the safety guidelines and hazard signs. Second, provide a proper housekeeping. Implementing a good housekeeping plan, keep the area clean and free from the waste to reduce the risk of injuries, for example like slip, trips and falls. The third, provide safety training. Employees should receive effective training on how to operate the machine and stay safe around them. They should understand why a particular guide exists and what specific hazard that they control. Last but not least, the personal protective equipment. So, employees involved in welding work in metal fabrication needs to have adequate personal protective equipment for their role. And more importantly, they need to have the training for a proper use of it. For example, the welder needs to be protected in accordance with the amount of exposure to heat, sparks, molten drops, fumes or UV radiation. Furthermore, employer also should provide the personal hearing protective equipment, which is PHP, to the workers. Ear muff and earplug are most common types of PHP. Employers should provide PHP to the workers and ensure workers know where to use hearing protection and how to use them correctly.